Look at this data flowing across a network, moving from point A to point B. But during a man-in-the-middle attack, those communications are intercepted and potentially altered entirely without the knowledge of the sender or receiver. As cyber threats grow more sophisticated, perimeter defenses like firewalls aren't enough. Security professionals have to proactively audit their internal networks to find out what an attacker can see once they are already inside. Today, we are going to use the Websploit Python framework. This is a dedicated, high-level man-in-the-middle auditing application, which is a distinct tool from the Docker training environments that share a similar name. By the end of this video, you will install this tool, configure its settings, and successfully execute a local network scan to map out connected devices. To follow along, you need two things: a standard Linux terminal and a Python 3 installation. Mastering this foundational framework takes the invisible traffic on your local network and turns it into visible, manageable data. We start with a blank Linux terminal. Our first objective is to pull the Websploit framework directly from its public code repository. This terminal mockup shows exactly what to type. You will use the git clone command with the repository URL, and then use the cd command to move into the newly created Websploit folder. Before the framework can run, it needs a specific set of supporting Python libraries to handle network requests and terminal formatting. You install these dependencies by typing pip3 install-r requirements.txt and pressing enter. Once those libraries finish downloading, the core framework itself must be compiled and installed onto your local system. Type python3 setup.py install to execute the build script and complete the setup process. When your terminal returns to the standard prompt without errors, the raw tool is ready. However, wielding it requires overcoming an immediate operating system barrier. Go ahead and launch the application by typing Websploit and hitting enter. By default, your OS blocks standard users from the network interface. You cannot interact with packets at the hardware level. Running attack modules now triggers an operation not permitted error. To fix this, restart using sudo. This grants root authority, providing direct hardware access. Relaunch the framework as root. Now type help to pull up the internal menu commands. This gives you a clear view of how to navigate the tool. Next, type show. This reveals the full list of available modules. These are the exact utilities attackers use to spoof addresses, intercept traffic, and compromise unencrypted data. Establishing these root privileges completes the environment setup. The framework is now fully authorized to interact with your network hardware for the next steps. Now that we have access, we can move from exploration to execution. We will focus strictly on the Scan Networks module, which is highly reliable and avoids some of the operating system compatibility bugs found in other parts of the framework. This terminal mockup shows our next step. Type Use Scan Networks to load this specific tool into your active prompt. Before running any module, you must verify its parameters. Type Options and press Enter. For a standard local network scan, the default settings listed here are sufficient. You don't need to modify any of the target variables. With the parameters confirmed, type Execute to initiate the network mapping sequence. There will be a brief pause. During this time, the framework is actively and aggressively interrogating your local router and all connected hardware. Then, the terminal will populate with a concrete list of active IP and MAC addresses. This output definitively strips away the anonymity of the network. You now have explicit proof of exactly who and what is sharing your local connection. Take a look at this table. If your screen shows these column headers populated with local device data, you have successfully deployed Websploit and mapped your environment. This mapped data exposes a harsh reality. Internal networks often operate on implicit trust, meaning any device listed here could potentially be targeted or used as a pivot point by an intruder. This brings us to a strict ethical mandate. Powerful scanning and man-in-the-middle frameworks must only ever be deployed on networks you own or where you have explicit legal permission to conduct security testing. Understanding how easily this local data is gathered is the first step toward better defense. In the next phase of your learning, you can use this insight to implement strict access controls, forming the basis of a zero-trust architecture. Studying the tools of the adversary provides the necessary insight to identify and patch vulnerabilities before they are exploited. This practice builds a more resilient and secure digital landscape.